The unexpected genius. The wind whipped across the remote research station nestled in the Atacama Desert, its stark landscape a perfect mirror of Maya Rodriguez's isolated childhood. At just 16, she was nothing like the typical researcher at the Global Aerospace Innovation Center. While other scientists wore pristine lab coats and worked in climate-controlled environments, Maya preferred her well-worn mechanic's jumpsuit, covered in grease stains and patches from countless personal projects. Her workspace was a controlled chaos of holographic displays, dismantled quantum processors, and experimental energy conduits. Unlike most teenagers who dreamed of social media fame or professional sports careers, Maya was obsessed with solving what most considered an impossible challenge, creating a propulsion system that could break the fundamental limitations of space travel. Dr. Elena Sharma, the center's lead physicist, watched Maya with a mixture of curiosity and frustration. "Another impossible design?" she asked, approaching the young researcher's workstation. Maya didn't look up, her fingers dancing across holographic interfaces. "Not impossible," she corrected, "just not yet understood." A three-dimensional model of an intricate engine design rotated slowly above her workspace, its complex geometry defying traditional engineering principles. The research center had initially hired Maya as a junior technical assistant, a courtesy position recommended by her mentor, a retired NASA engineer who had recognized her extraordinary potential. What began as a standard internship quickly transformed into something unprecedented. Maya's ability to conceptualize quantum mechanical principles in ways that challenged established scientific understanding made her both a marvel and a potential liability. Her current project focused on manipulating quantum entanglement as a potential method of propulsion. While most scientists considered this purely theoretical, Maya saw it as a practical engineering challenge. She believed that by creating a precise quantum resonance field, a spacecraft could essentially fold space around itself, dramatically reducing travel time without violating known physical laws. "The mathematics don't support your hypothesis," Dr. Sharma said, examining the holographic model. "You're suggesting we can create a quantum tunneling effect at a macro scale, which goes against everything we currently understand about quantum mechanics." Maya smiled, a rare moment of genuine emotion breaking through her typically serious demeanor. "Science progresses by challenging what we believe we understand, Dr. Sharma. Every major breakthrough looked impossible until someone proved it wasn't." Her background was as unconventional as her approach to science. Raised in a small community near the Bolivian border, Maya was the daughter of engineers who had dedicated their lives to sustainable technology. Her parents had died in a research expedition when she was 10, leaving her with an inheritance of curiosity and an unquenchable desire to push technological boundaries. The Global Aerospace Innovation Center had become her home, its vast resources and cutting-edge facilities providing her the tools to transform her radical ideas into potential realities. Most of the senior researchers viewed her as an anomaly, a prodigy whose theories were more science fiction than practical research. But Maya understood something fundamental that her colleagues missed. Innovation wasn't about incremental improvements, it was about radical reimagining of what was possible. Her quantum propulsion concept wasn't just about faster space travel, it was about fundamentally changing humanity's relationship with the cosmos. "I've isolated a quantum resonance pattern," she announced one evening, her voice cutting through the quiet hum of sophisticated equipment. "It's not just a theoretical model anymore. I can demonstrate a microscale quantum displacement." Dr. Sharma approached, skepticism etched into her professional demeanor. "Show me." Maya activated a small experimental chamber. Inside, a series of precisely calibrated quantum processors began to vibrate at frequencies that seemed to make the very space around them shimmer. A tiny metallic sphere suspended in the chamber began to move, not through any visible mechanical force, but by seemingly bending the fabric of space itself. For a moment, the impossible became possible. The implications were staggering. If Maya could scale this technology, it would revolutionize not just space travel, but humanity's entire understanding of physics. Traditional rocket propulsion would become as obsolete as horse-drawn carriages. Little did Maya know that her work was being monitored, not just by her colleagues at the research center, but by entities far beyond Earth's atmosphere. Alien civilizations with centuries of technological advancement were about to receive a profound message: humanity was no longer a species to be overlooked. The quantum displacement experiment was just the beginning. Maya Rodriguez was about to change everything humanity thought it knew about space exploration. First breakthrough. The International Scientific Consortium rarely convened emergency meetings. Their last unscheduled gathering had been during the discovery of gravitational wave detection a decade earlier. Now, they were assembling to discuss a discovery that would make even that breakthrough seem mundane. Dr. Marcus Chen, the consortium's lead physicist, adjusted his glasses as he reviewed the preliminary reports from the Global Aerospace Innovation Center. Maya Rodriguez's quantum displacement experiment had initially been dismissed as an anomaly, a curious but ultimately insignificant blip in scientific observation. But repeated tests revealed something extraordinary. It's not just a laboratory trick, Maya explained, standing before a panel of the world's most distinguished scientists. Her presentation was meticulously prepared, each slide a testament to months of rigorous research and countless sleepless nights. The quantum resonance field we've developed can create localized spacetime compression. The conference room was a sea of skeptical faces. These were scientists who had dedicated entire careers to understanding the fundamental limitations of space travel. Propulsion had always been about burning fuel, creating thrust, following the same principles that had governed rocket science for decades. Dr. Elena Sharma, who had initially been Maya's most vocal critic, now stood as her strongest advocate. The implications are profound, she interjected. Traditional space travel relies on chemical propulsion or ion drives. Maya's approach doesn't just improve speed, it fundamentally reimagines how we move through space. The prototype was small, no larger than a basketball. But within its intricate quantum processors lay a technology that could rewrite the rules of interstellar travel. Initial simulations suggested that a spacecraft using this technology could theoretically traverse distances that would take conventional ships decades in mere weeks. How is this possible? Asked Dr. Rajesh Kapoor, a renowned astrophysicist from the Indian Space Research Organization. We're talking about manipulating spacetime at a macro scale. Every previous attempt has failed catastrophically. Maya's explanation was both simple and mind-bending. By creating a precise quantum entanglement field, the prototype could essentially fold space around itself. Instead of moving through space, it would make space move around the vessel. The energy requirements were minimal compared to traditional propulsion systems, and the potential for exploration was limitless. Behind the scientific marvel was a deeply personal motivation. Maya had grown up hearing stories of her parents' final research expedition, a mission that had ended in tragedy. Their dream of pushing human technological boundaries had cost them their lives. Now, she was completing the work they had started. The consortium's decision wasn't unanimous, but it was decisive. They would fund a comprehensive research program to develop and test Maya's quantum propulsion concept. Preliminary funding of $500 million was approved, with the potential for billions more if initial tests proved successful. What the scientists didn't know was that their meeting was being monitored. Not by terrestrial intelligence agencies or competing research institutions, but by something far more distant. In the vast darkness between stars, advanced sensors picked up the first hints of a technological breakthrough that would soon reshape galactic dynamics. The Zorn Collective, a millennia-old civilization that had long considered humans a primitive species, was about to receive a wake-up call. Their long-held belief in human technological inferiority was about to be challenged in ways they could never have anticipated. Back at the research center, Maya worked tirelessly. The funding was important, but it was never about the money. Each calculation, each refined quantum processor brought her closer to understanding the universe in a way no one had before. Her prototype wasn't just a technological marvel, it was a bridge to humanity's future among the stars. We're going to change everything, she whispered to herself, surrounded by holographic displays and humming quantum circuits. The universe was about to get a lot smaller, and humanity was about to get a lot bigger. Galactic attention. The transmission arrived encrypted through channels that most diplomatic communication networks couldn't detect. Ambassador Lyra Corvin of the Galactic Collaborative Council leaned forward, her iridescent skin shifting colors with her mounting frustration. "Explain again," she demanded of her chief scientific advisor, a silicon-based life form named ZX-9. ZX-9's crystalline form pulsed with data streams. "The humans have developed a quantum propulsion system that defies our current understanding of space-time manipulation. Our long-range sensors detected a technological signature that shouldn't be possible for a species at their developmental stage." The Galactic Council chambers were a marvel of interstellar architecture, a massive spherical structure that floated in the neutral zone between three major star systems. Representatives from over 247 known sentient species gathered here, a testament to millennia of diplomatic negotiations and technological exchange. Humans had always been considered a curiosity. A young species, barely space-capable, often viewed as potential resources rather than serious technological contenders. That was about to change. "We need more information," Ambassador Corvin decided. The Collaborative Council didn't believe in military intervention, their approach was diplomatic, analytical, and meticulously calculated. "Prepare a diplomatic mission to Earth." Meanwhile, at the Global Aerospace Innovation Center, Maya was unaware of the galactic-scale attention her work was generating. Her focus remained singular, perfecting the quantum propulsion prototype. The initial tests had been promising, but scale was the ultimate challenge. Dr. Elena Sharma entered the lab, her face a mixture of excitement and concern. "We've received a diplomatic communication," she said. "The Galactic Collaborative Council wants to send a delegation." Maya barely looked up from her work. "Diplomatic communication? About what?" "Your quantum drive," Elena explained. "Apparently, it's caused quite a stir among extraterrestrial scientific communities." The prototype had grown from the basketball-sized initial model to something closer to a small spacecraft module. Quantum processors lined its interior, creating a complex network that seemed to shimmer and bend light around its surface. Traditional understanding of physics suggested what Maya was doing was impossible, yet here it was, functioning with increasing stability. What made the quantum drive revolutionary wasn't just its potential speed. It fundamentally reimagined space travel. Traditional propulsion was about pushing against something, rocket fuel expelling to create movement. Maya's design essentially wrapped space around the vessel, creating a bubble of compressed spacetime that could move faster than light without violating fundamental physical laws. The first official response came 3 weeks later. A diplomatic shuttle arrived, not from a human government, but directly from the Galactic Collaborative Council. The vessel was a marvel of technological elegance, its surface a shifting membrane that seemed to breathe with internal energy. Ambassador Zara Cleth emerged, a being that seemed to be simultaneously solid and translucent. Her species had been spacefaring for over 10,000 years, and she had personally witnessed the technological evolution of hundreds of civilizations. "We are intrigued," she said, her translation device rendering her alien language into perfect English. "Your quantum propulsion concept challenges everything we understand about space travel." Maya, dressed in her standard mechanics jumpsuit, looked decidedly unimpressed. "It's just physics," she replied. "Most people just stop asking questions too early." The diplomatic mission was officially classified as a scientific exchange. But both sides understood the subtext. This was about more than technology, this was about humanity's potential place in a much larger galactic community. Cleth's initial report to the Galactic Council was brief but profound: "Humans are not what we expected. They are far more dangerous, and far more promising, than our long-range analysis suggested." The universe was about to get much smaller. And humanity was about to get much, much bigger. The prototype. The test facility was a marvel of engineering, nestled deep within the Atacama Desert. Massive radiation shields and quantum-dampening fields surrounded a launch area that looked more like a cathedral to scientific ambition than a traditional spacecraft testing ground. Maya stood before the full-scale prototype of her quantum drive spacecraft. At 50 meters long, it was a sleek, almost organic-looking vessel that seemed to blur at its edges, a visual representation of its ability to manipulate spacetime. Years of research, countless failed experiments, and unimaginable technological challenges had culminated in this moment. Dr. Marcus Chen approached, his usually reserved demeanor tinged with barely contained excitement. "Final systems check complete," he announced. "We're ready for the first full-scale test." The international team assembled represented the most diverse group of scientists ever gathered for a single project. Experts from 23 different countries stood by their monitoring stations, each responsible for a critical aspect of the test. Representatives from the Galactic Collaborative Council observed remotely, their advanced sensors probing every microscopic detail of the preparation. Ambassador Zara Cleth's holographic projection flickered to life. "Remarkable," she murmured, her translucent form studying the vessel's complex quantum matrix. "Your species continues to surprise us." Maya's focus was absolute. Unlike most 22-year-olds, she showed no signs of pre-test nervousness. This was the culmination of a dream that had begun in her childhood, a dream inherited from her parents and fueled by an unquenchable curiosity about the nature of space itself. The quantum drive was more than just a propulsion system. It was a complete reimagining of how spacecraft could interact with the fundamental fabric of the universe. Traditional rocket science relied on massive fuel expenditures and linear momentum. Maya's design created a quantum entanglement field that essentially folded space around the vessel, allowing it to move without traditional concepts of acceleration or resistance. "Quantum stabilization at 98.7%, announced Dr. Elena Sharma from her monitoring station. "All primary and secondary systems are green." The test parameters were deliberately conservative. They weren't attempting an interstellar journey, not yet. The goal was a simple quantum displacement, moving the spacecraft approximately 500 kilometers instantaneously, with absolute precision. As the countdown began, the air itself seemed to change. Quantum sensors detected minute fluctuations in spacetime around the vessel. The ship didn't look like it was preparing to move, it looked like reality was subtly bending around it. Initiating quantum drive in 3, 2, 1. A momentary shimmer. A brief, almost imperceptible distortion of light. And then nothing. For several agonizing seconds, absolute silence filled the test facility. "Status report," Maya commanded, her voice steady. The monitoring systems erupted with data. Not just data, impossible data. The spacecraft had not just moved 500 kilometers. It had instantaneously transported itself to a precisely calculated point, with zero energy loss and zero time dilation. Sensors showed the vessel intact, its quantum matrix stable. More importantly, it had moved exactly as calculated, down to the millimeter. Dr. Chen's hands were shaking as he reviewed the initial data. "This changes everything," he whispered. The Galactic Collaborative Council's remote observers went silent. This was more than a technological breakthrough. This was a fundamental challenge to everything they understood about space travel. Ambassador Cleth's hologram turned to Maya. "You realize what this means?" she asked. Maya's response was typical of her, direct, unembellished. "We're going to explore the universe," she said simply. "And nothing will ever be the same again." The prototype represented more than a technological achievement. It was humanity's first true step into a larger universe, a declaration that they were no longer just observers, but active participants in the grand cosmic narrative. The stars suddenly seemed much closer. Confrontation and validation. The aftermath of the quantum drive test sent shockwaves through both human institutions and the galactic diplomatic community. What had begun as a scientific experiment had become a moment that would redefine humanity's place in the universe. The Zorn Collective was the first to respond, and their response was anything but welcoming. Their massive diplomatic vessel entered Earth's solar system without warning, its obsidian-like hull blocking out entire sections of the sky above the Global Aerospace Innovation Center. "This technology is a threat," declared Grand Arbiter Vexnara, the Zorn's chief diplomatic representative. His holographic projection filled the United Nations Emergency Conference Room, his crystalline form shifting with barely contained aggression. Quantum space manipulation at this level disrupts the carefully maintained balance of galactic technological progression. Maya sat quietly at the table, flanked by Dr. Elena Sharma and Ambassador Michael Rodriguez, no relation, but a seasoned diplomat who had been briefed extensively on the quantum drive's implications. Where others might have shown fear or defensiveness, Maya displayed only calm curiosity. The Zorn Collective represented the oldest known spacefaring civilization in the known galaxy. They had overseen technological development for thousands of species, carefully controlling the pace of technological advancement to prevent potential conflicts. Their system was built on strict regulation, controlled innovation, and a belief that no emerging species should develop technology too quickly. "Your assessment is incorrect," Maya stated simply. No elaborate explanation, no defensive posturing, just a direct challenge. Grand Arbiter Vexnara's crystalline form pulsed with irritation. "Explain." "Technology isn't a threat," Maya replied. "It's a tool. The intention behind it determines its value. Our quantum drive isn't about conquest or destruction. It's about exploration, understanding, connection." The diplomatic tension was palpable. The Zorn had never encountered a species that so brazenly challenged their authority. Most emerging civilizations would have been intimidated by their massive vessel, their millennia of technological superiority. But humans were different. Ambassador Rodriguez understood the game being played. This wasn't just a scientific discussion, it was a test. The Zorn were probing humanity's resolve, their technological maturity, their potential as a galactic species. A series of challenges were proposed. Not military confrontations, but technological trials designed to demonstrate the quantum drive's capabilities and limitations. Each test was more complex than the last, each designed to expose potential flaws in the technology. Maya approached each challenge with the same methodical approach she had used in developing the drive. Where the Zorn expected complexity, she offered elegant simplicity. Where they anticipated defensive posturing, she provided transparent explanation. The most critical test involved a precise quantum navigation challenge. The Zorn provided coordinates in a region of space known for its extreme gravitational distortions, a place where even their most advanced ships struggled to maintain stable trajectories. The prototype quantum drive spacecraft was launched. Minutes turned into hours. The Zorn observers grew increasingly agitated. Their sensors showed the human vessel not just navigating the challenging region, but doing so with unprecedented precision and efficiency. When the spacecraft returned, its quantum matrix was not just intact, it was virtually unchanged. Grand Arbiter Vexnara's crystalline form went completely still. This was unprecedented. No emerging species had ever passed their most challenging technological assessment so completely. "You understand what this means," the Zorn representative finally said. Maya's response was simple. "We're ready to explore. Not to conquer. Not to compete. But to understand." The universe had just gotten a lot more interesting. And humanity had just proven they were far more than anyone had ever anticipated. A new era. 5 years had passed since the quantum drive's first successful test. The world, no, the galaxy, had transformed in ways no one could have predicted. The Global Interstellar Research Center stood as a testament to humanity's newfound status. What was once a small research facility in the Atacama Desert had become the most important scientific hub in human history. Spacecraft from multiple alien civilizations now regularly docked at its orbiting station, a symbol of the unprecedented cooperation that had emerged. Maya Rodriguez, now 27, stood in the observation deck overlooking the massive quantum drive production facility. She was no longer just a scientist, she had become the chief architect of humanity's interstellar future. "The Andromeda mission is ready for launch," announced Dr. Marcus Chen, approaching her with a holographic display. The mission would be humanity's first intergalactic journey, a voyage that would have taken millions of years with traditional propulsion, now possible in a matter of weeks. The Galactic Collaborative Council had undergone its most significant restructuring in millennia. Humanity, once considered a minor, primitive species, was now a key strategic partner. The quantum drive had done more than revolutionize space travel, it had fundamentally altered the dynamics of galactic interaction. Ambassador Zara Cleth, who had been one of the first to recognize humanity's potential, now served as the primary liaison between Earth and the broader galactic community. "Your species continues to surprise us," she often said, a statement that had become something of a running joke among diplomatic circles. The quantum drive's implications went far beyond space travel. The fundamental understanding of spacetime that Maya had unlocked was transforming multiple scientific disciplines. Medical technology, energy production, communication, everything was being reimagined. Maya's parents, whose unfinished research had inspired her journey, would have been proud. The dream of pushing human technological boundaries had been more than realized, it had been transcended. As the Andromeda mission preparation continued, Maya reflected on the journey. It hadn't been about creating the fastest ship or proving human superiority. It had always been about understanding, about pushing the boundaries of what was possible. A young researcher approached her, holding a tablet with complex quantum calculations. "Dr. Rodriguez," she said, "we've discovered something interesting in the quantum matrix calculations." Maya smiled. The journey of discovery was never truly over. The observation deck overlooked a facility that was now launching ships to destinations once thought impossible. Vessels that could traverse light years in moments. Technology that had transformed humanity from a planetary species to a truly interstellar civilization. Outside, the stars seemed closer than ever before. In the distance, a quantum drive spacecraft prepared for launch, a sleek, almost living vessel that represented humanity's boldest step into the unknown. Each launch was a testament to human curiosity, human potential, and the unquenchable desire to explore. The universe was no longer a distant, unreachable frontier. It was home. And humanity had just been invited in.